autonomous precision spray painting with little Wally here. Got a little spray paint. You might ask why? Why would you do that? That's a good question. That's cool. Anyway, this video is going to be broken up into two parts. The first part, how do we get that precision accuracy out of this new RTK GPS? So setting up the RTK GPS, and then how do we get the robot to spray this can for us so we can do some 2D vandalism. Let's jump into the video. You're right in my shot, bro. You're right in my shot. What, do you want some camera time? Alright, now we can jump into the video.
Ladies and gentlemen, your host of the Drone Dojo Show, Kayla Berquist.
Thank you. You're too kind. Anyway, Buster, you have a good weekend? Hey, did you hear this? Hear this? Apparently, RTK GPS is in the news. You know, conventional GPS gets about 5-meter accuracy, while RTK GPS gets about 1 centimeter level accuracy. Guess that's one place where the bigger isn't better. Alright, so here we are live out in the field with a little demo of how conventional GPS works. Now, this is the GPS module that you're probably most familiar with, and if you built a DIY drone or rover, you likely have this on your build already. It looks something like this, and it has a little probably M8N chip on it. We'll make note of that. But basically, you know, your GPS module is getting readings, but the error on the conventional GPS is 5 meters. So what does that mean? The actual location of your vehicle is right here, but the reading might be saying it's over here or it's over here. Now, that is quite a wide margin of error, but it might not matter for your particular application. But if you're doing, I don't know, drone delivery and you're going in someone's backyard, maybe you need more precise GPS location. Maybe you're doing precision agriculture and you need to know exactly the lanes of your crops. Then you need something more precise than 5 meters. So now we know kind of how conventional GPS works. Let's jump into RTK GPS so we can kind of understand it. So the first step in an RTK GPS system is this. We have our GPS set up here, and this is actually off of our robot. This is called the base station, and it's a dedicated GPS setup. Now, at this base station, before we're even concerned about receiving accurate readings, we're going to first survey in, try to get a very accurate location of where this GPS module actually is. Then we will start getting readings in from satellites, okay? And then if we know, think about this, if we know the actual GPS location of the base station, but our current reading is saying we're over here, you know, at this waypoint, this is our actual waypoint, but we're getting reported we're at this waypoint, which is an error because this is a known position where the base station is. Then we have this known error that we can account for, right? So keep that in mind. This is all off of our vehicle right now. Now let's say we're out in the field with our rover and we have, now this might be confusing. In an RTK GPS setup, the fixed location module is called the base station, and the GPS module that moves is called the rover. It's kind of confusing because this robot is also called a rover, but forget about that for now. So we're out in the field. We have our RTK GPS on our vehicle here, and it's reporting that our current position is here, even though the actual position is here. But our flight controller has no idea about this difference in position. But lucky for us, we have a base station that has this error already. So what can happen is we will transmit this error over to our robot here. And then we can be like, oh, well, the GPS is saying we're right here, but we're receiving note from the base station that we have to account for this type of error. So then we can get our actual position down to centimeter level accuracy. Okay, but it's all dependent on initially getting this really good, precise GPS coordinate of your base station. And then you can transmit the errors to your robot to get a very accurate reading on your robot that's moving all the time. Now, there are different states of GPS that will be good to know for this video. The first is 3D Fix. These are just estimates, but in 3D Fix, that state, GPS state, gets around 5 to 8 meters of accuracy. So, actual location of the robot's here, could be reporting or reading in that it's here, could be reading in it's here. It's a wide radius of error. And that 3D Fix, you can get that with this M8N GPS module. Then we have 3D GPS. That's a little bit more accurate of a GPS state, and that's about 3 to 5 meters. You can also get that with if you get a lot of good satellite connections with this M8N GPS module. So that's 3D GPS. Then we have RTK Float. Now we're starting to incorporate a base station here, but in RTK Float, there's still room for improvement, but it's pretty accurate. You get about 1 to 2 meters of accuracy. And this here is the Here 3 GPS, and then the Here Plus base station. Okay, then the most precise GPS state is RTK Fixed. That is when we're getting to, below even 0.1 meters, but just let's say 0.1 meters to 0.5 meters. And RTK Fixed is the most precise GPS location state, and you can get that with a really good base station and antenna. It's your fault. I didn't want to have to do this, but Rocky is about to get tormented by his favorite friend, Wally the robot. And the madness will continue until you like and subscribe. So, if you like torturing dogs, I guess you like not subscribing to my YouTube channel.
Spend all your time waiting for the second chance, for a break that will make it okay. In the arms of the angel.
Okay, so in this project, we're going to be using the ArduSimple carrier board for the F9P U-BLOX GPS chip, along with this dual band antenna here. And we're going to need one of these sets for the rover, the vehicle that's moving around, and the static base station. So 2 sets of these. Now, if we are using the pixhawk flight controller, that is going to have a different connector than what is on the ArduSimple carrier board. We'll see here, these connectors we're looking at are called DF13, and the GPS should plug into there. And on the ArduSimple, that is a JST plug. So what we need to do, if we want these two to communicate, is make a custom connector. So here I got a couple different connectors. On the left, we have the 6-pin DF13 that can plug into the pixhawk. Then on the right, we have the 6-pin JST. So you can get these kits on Amazon for pretty cheap. Just comes with pre-crimped cables. And this is the pinout. So on the pixhawk, it goes 5 volts, then TX, RX, then slots 4 and 5 are open, and then you have ground. And with the TX, RX UART communication, the TX line goes to the RX line on the other device. So on the ArduSimple board, we have 5 volts, RX, TX, slots 4 and 5 are open, then you have ground. And we just need to solder these two cables together like that. And then I just simply wrap a little bit of electrical tape around it to reduce some noise. And there you go, you got your cable. Okay, so now we need to figure out how to mount this ArduSimple board to our vehicle. So this is the standard pixhawk plate that comes in a lot of the kits that we use in these videos. And this is what it kind of looks like. You just install that to the Raspberry Pi with some spacers, some standoffs in between, and it looks something like that. You mount the pixhawk on top, and then you're good to go. What we're going to do with this mount, actually, is modify it so we can put something on top of it. So here you see we've created new mount points. So right here, 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 and here. We have new mount points that we're going to kind of build up with. these inner mount points will connect the mount to the Raspberry Pi, and then we can, kind of like a skyscraper, mount things to the outside of this mount. And it'll be a pretty cool design. So on top of this, we're going to have this ArduSimple mount that we designed. Now on the outside, the 4 outside holes will mount to the outside holes of that new pixhawk mount, like there. And then the inner 3 mounts will simply secure down with screws the RTsimple board to this 3D printed mount. So in the real world, it'll look something like this. This is the old mount. We've already showed you. There's the new mount. Ignore the kind of stringy looking layers. I had an extrusion problem that is now fixed. But anyways, it'll look something like that. So we have some big spacers there, and then the pixhawk mounts in the middle like normal. And then we can put on top that RTSimple mount, just like that. So we can kind of go vertical with these mounts. So now let's put it on the vehicle. Got our little mounting tape there, pixhawk secured. And make sure to plug in all of the wires before you secure the RTSimple mount, because you don't really have access to it once that's installed. And here we have our cable we made already plugged into the GPS port, just like that. Then we'll just simply plop on top that RTSimple mount with these standoffs. I think they're about 8mm standoffs. And then we can plop on the RTSimple carrier board. And then you see here we have the antenna plugged in and the GPS cable plugged into the RTSimple board. So we can put another layer on top of that, secure that down with 4 screws, and then we can install our U-BLOX antenna, our dual band antenna. Now, as stated before, it does help to have a ground plane. You get a better signal, and this is actually magnetic, so it just kind of sticks on there. Through some futuristic technology, we are securing this down with some hot glue here. Nothing too fancy, just securing that down. And then here's a side look of our little skyscraper setup. We got the Raspberry Pi, the pixhawk, the RTSimple board, and then the antenna on top. So this is the base station setup. Is the identical hardware that is going on the Rover, except now it's on a static tripod. I just have one of these RTSimple boards mounted on the side here with one of the dual band antennas. Helpful to have one of these grounding planes. And then yeah, portable, ready to go to the field. And this is how you will plug into Mission Planner with a little micro USB cable. We'll cover that here in a sec. Say what's up to Rocky. Alright, now that we got the RTK stuff set up on the vehicle side, the Rover side, and we got RTK set up on the static base station, let's go out into the real world. We'll show you how to set that up, get that absolute position of your base station so that you can start sending those error coordinates to your vehicle and start getting that centimeter level accuracy. Let's go out in the field where it's 100 degrees outside. It's literally over 100 degrees. I'm gonna be lazy and not walk over to the little park over there. We're gonna try and get a little RTK positioning in my front yard. Okay, so now how do we get that really accurate GPS location of the base station? Well, it's pretty simple actually. Just plug the USB, micro USB of the RTSimple into the USB of your laptop, then open up Mission Planner. And then head on into Setup, go to Optional Hardware, then RTK GPS Inject. Now, from this drop down here by the Connect area, we need to select the COM port of the device. Mine is COM46, and then hit Connect. Then after you hit Connect, you will see a lot of the satellites that are available to you here at the bottom. That's what all these bars are. Now this red line actually indicates if you're getting a good signal or not. If the bar is above the red line, you get a good signal. Okay, so what is this section here? This is pretty important. This is survey in accuracy. So how accurate do we want the location of our base station to be? The higher our survey in accuracy is, the less time it will take for Mission Planner to calculate that very precise GPS location. The lower you go, it's the opposite. It might take a little bit. So right here, I'm setting that to 2 meters, so it shouldn't take too long. And then once you have your survey in accuracy set. Go ahead and hit restart. And then over here, you should start to see observations, which is how many observations of satellites have you seen, and then the current accuracy of your GPS location. So here we have about a 2-meter radius of accuracy. And the more observations you get, the lower the accuracy gets, the better the accuracy gets. Then after some time, you should get to under that survey in accuracy you want. And at that point, you will connect your telemetry module here up top. So mine is COM5, and then hit connect, and that will start transmitting over the RTK error correction data to your vehicle. So that's how you get that really precise RTK data.
Right now, only getting 3D GPS, which isn't even RTK float, which is one step away from RTK Fixed, and I'm pretty sure it's because of all the trees. Pretty sure it's because of all the trees. Not an ideal place for an RTK base station. So, might have to go into an open area, like a hot field over there. Okay, so we are out in the field with a little cigar. Oh, got the little TikTok dancing camera. Not gonna be doing any dances. Right now we're surveying with the RTK base station. Gonna get a good location here.
Okay, so now that we are out in a wide open field and not surrounded by a bunch of trees that are blocking our signal, we should be able to get a really good RTK signal this time. So I set the survey in accuracy to 1 meter instead of 2 meters this time. And you can see now already the signal coming in on these satellites with all these bars is much, much better than what we were getting back at the house with all the tree coverage. It took about 8 minutes to get the GPS coordinates of the base station to under 1 meter of accuracy, which is really not that bad, especially if you mark it. And you can just simply use that waypoint for future missions without having to survey in that accuracy. So we are almost to that sub 1 meter accuracy. And once we get that, as stated before, we'll just connect the ground control station to the rover with telemetry. We'll just hit connect here at the top right, and that'll transmit over the error corrections to the rover. And then let's check out the map here. So first of all, you'll notice we're in an area that has very minimal tree coverage. So we have wide open line of sight to the sky, getting good connections with the satellites. And take a look here at the GPS signal. We're in RTK Fixed, which means we are in that centimeter level of accuracy now.
Okay, so I've just designed this beautiful, beautiful mount for the servo to hook onto this vehicle to initiate the spray paint. Let me show you right now. And first of all, what you're thinking, oh, pretty sure it's 100 degrees in this house, all right? It's Oklahoma. You don't understand what's going on here. Don't judge me. Don't look at the filth, don't look at the filth. So what I've designed here is this beautiful hot glue based servo mount. You thought I'd be fancy with the old 3D printed mounts again. Nope. We're trying out the hot glue mounting method. We got about 3 pounds of this hot glue on there. And the thought is that the pixhawk will trigger the signal to this servo and it'll trigger it. So I'm gonna try it out indoors against all wisdom. Alright, so that was a big fail. It wasn't a fail on the part of my brilliant hot glue mount. It's actually a fail on the torque of the servo. See, I'm going to trigger the servo high real quick, and you'll see it does actually engage the button. It just doesn't have enough torque to actually let it go. See, I'm going to press on top of the servo horn now, and it sprays. There's just not enough torque coming off of this little guy. I think I have an idea. Boom, 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 boom. Oh baby, here we go. Now it's high. I'm gonna press the button. I gotta press the other button real quick because it's gonna spray all over. Now I'm going low. Get low with it. Ah! Woo! Woo! Man. Alright, we got a working spray can that'll run autonomously. Let's put that thing back high. Get it back high. Speaking of high, I'm getting a little high with all these fumes going around, man. You know what I'm saying, bruh? Anyway, got that thing figured out for tonight. Let's have some fun with this thing tomorrow. Uh-oh. Tragedy has struck. It's a freaking tragedy. Look at this. Look at this. It doesn't even press the button anymore. My stupid design. Let me take this out of my mouth. This stupid design didn't work. So it appears that the hot glue is not enough to keep the servo secured. So what I did was get a little bit of elastic band, wrap it around there a couple times with the hot glue, and now we appear to have a good, hacky, but workable solution. So how is the freaking rover supposed to shake this thing? I have an idea. I wrote up a function called shake that's going to jitter the robot back and forth. It's going to send to 1400 PWM, 1600, so the robot's going to go back and forth for, in this function, 5 seconds. It'll look something like this. It works a lot better than I thought it was going to. That should be pretty good.
And now for a quick word from our sponsor for this video, Dojo.
Hi, Billy Mays here. Do you fantasize about doing your own cool DIY tech projects of your own, but just end up watching others do cool DIY projects on YouTube? Well, we have just the product for you. Introducing Jetson Smart Rover Kits from Dojo. We'll ship you the Yoshi egg. You just follow the build manual. And create your own green dinosaur that you can mount yourself and ride down the Rainbow Road.
Warning. Rover kits will cause extreme loss of all of your friends and loved ones because you will annoy them out of your life because you are talking about your DIY projects all the time. Buyer discretion is advised.
Okay, I think we're ready to draw some smiley faces with spray paint, autonomously. So, here is our mission. We're out at the park, at the location where we have verified to get a good RTK signal. And here we have our auto mission. It is 22 commands long, and I think you can kind of see the smiley face, but here's kind of how it's going to work. We're going to initially command the rover to drive to waypoint 1. Once it gets to waypoint 1, set the servo to low. So the servo number is 9, and this sets it low. So that's going to trigger the spray paint to start going. And then we're saying go to the next waypoint, which is waypoint 3. Then go to waypoint 4. Then go to waypoint 5. Look at that, we have a smiley face. Well, no eyes yet. We have a smile. Then, after we get to waypoint 5, we have to put the spray paint back high. So here we're doing do set servo command, servo 9, put that high. And then we have a little delay command right here, just delay the mission by a second. And then our robot isn't skid steer, so it's not able to turn in place. So in order to get a good eyeball spray, we need to get good alignment. So then we're commanding the robot to go to waypoint 8, waypoint 9, and then from waypoint 9, we can drive to waypoint 10 on a straight line to get that really nice looking eyeball, you know? That is, once we get to this waypoint, then we're setting the servo low again, and then that'll start spraying, and then once we get to the other end of the eyeball, we'll set it back high, and then you get the picture. It's gonna roll the waypoint 15, waypoint 16, waypoint 17, set the servo low, go to the other end of the eyeball, set the servo high, and then return to launch, wherever it launched from. Now, you might be noticing there is one flaw with this mission, which is, where is the shaking? How are we reloading the spray paint? Because we have our shake function, but that's in a Python Dronekit script. How are we going to trigger that? All right, so how are we going to get that shake function out of our rover when our auto missions don't have any commands to shake that booty? All right, so what I did was make a mission, a Dronekit script called Smiley Vandalism. Smiley Vandalism. So what is this doing? This is actually going to be the script that we call to run this auto mission. So the auto mission, when we hit right, automatically gets uploaded to the rover. So it will run this mission if it's switched into auto mode. Doesn't need this Python script. But instead of our controller calling auto mode, it's going to be the Python script that calls auto mode. So here, we're getting that connection, arming the vehicle, setting the vehicle into auto mode, and at this point in the script, the rover will start the auto mission. Okay, so when we get to, let's see, the end of the smile, we want to pause the script so that we can trigger our shake function right here, right? Because this is what's going to reload the spray paint with more paint because we need to shake it. So after the smile's over, we're going to stop this auto function. And how do we do that? When vehicle.commands.next is not 7. So what is the 7th command? It's this delay right here, right after the smiley face is drawn and the servo's high. So we're in this while loop until the next command is 7. And when it is 7, then we'll break out of this while loop. So we're at the end of the smile, and then we're putting the vehicle into guided mode. And now we can call our shake function. So we're out of auto mode now, and now we get to call our shake function. So the rover's going to shake back and forth, get that can reloaded, and then after the shake function's over, we'll trigger the vehicle back into auto mode. So we'll just pick up where it left off. So then it will go to waypoint 8, waypoint 9, and then again, so we have a reloaded spray can, but we want to reload the spray can at the other side of the first eyeball. So that's what we're doing here. While the next command isn't 14, just loop and loop and loop. But once this is 14, we know we're at the other side of the eyeball here. So again, we're going to trigger the script into guided mode to stop the auto mission from happening, and then do the shake function. And then we do that again for the other eyeball. So that is how we can use some custom code on our auto mission that isn't a part of the auto functionality normally. We just wrap it with a Python Dronekit script, and we pull the waypoints where we want to input our custom functionality, like shaking the rover, and then we just put it back into auto mode. So that's how it's going to work. So let's go out into the field and test this out.
I do talk a lot of crap on DJI, well deserved, but you can't argue with them being the best cameras that can fly on the market. You just can't argue with it.
I will walk 500 miles and I will walk 500 more.
changed out the black one for the yellow one. It works for now. Let's try it out. Come on, baby. Don't let me down, yellow. That's hard to see on the sky cam. Don't let me down, yellow. Okay. Take it off. Take it off. Hey, hey. Hey, hey, hey. This way, buddy. Alright, let's get that first eyeball. Let's get that first eyeball. Oh, perfect! Perfect! Look at that. You can't beat that. You can't beat that. How you doing up there, drone? Kind of neglecting you. You're kind of on your own. All right, let's do that again. All right, second eyeball test incoming. Incoming. Oh no! Move the drone up. Move the drone up. What we got here? Okay. Okay. Not too bad. Not too bad. Get a little twerking going on there, Wally. That's a good mission. If only yellow would show up better. All right, good job, good job.
So you want to see what that smiley face would look like without RTK GPS? Check this out. So this is a little blue smiley face we did by my house, and you can see here that the lips of the smile are about 5 feet of separation between the top lip and the bottom lip. So it's a pretty wide difference in repeatability right there. Whereas on our actual RTK smiley face, we had about a foot of precision there. And really, that could probably be a lot closer, but our parameter WP radius was set to about half a foot, which means that if the robot gets within half a foot of the waypoint, then it'll just continue to the next waypoint. But with this blue non-RTK smiley face, we can really get a sense of what that RTK setup actually gets us. Alright, that is how you vandalize public parks with giant smiley faces that you can only see from the sky. That's how you do it. That's how it's done. And so now that we have centimeter level positioning with our RTK capabilities and spray paint capabilities, Let me know in the comments what the next project should be with those two things. If you're interested in toying around with your own rover, we actually have these exact models available for purchase. As you can see, you can do a lot of cool things with them. Just press, I don't know if the button's up there, it's somewhere over here. And if you haven't liked and subscribed yet, I mean, you're all the way at the end of the video, and you haven't liked and subscribed yet? It's like a one-directional relationship. I'm giving, and you're just taking. What is this? Come on, press the button. Show me you care. All right, I'll see you next time.